Imagine a time when the universe as we know it didn't exist. No stars, no planets, no galaxies, nothing. This was the state of the cosmos about 13.8 billion years ago. Today, we understand that the universe began from a single point, an event that would shape everything we see around us. This event is known as the Big Bang. But what is the Big Bang Theory? How did it all begin, and why is it so crucial to understanding our universe today? To grasp the Big Bang Theory, we must first understand that the universe 13.8 billion years ago began as an infinitely small, infinitely dense point. This point contained all the energy, matter, and space that would eventually expand into the vast cosmos we now observe. This wasn't an explosion in the traditional sense, like a bomb going off. Instead, the Big Bang was the rapid expansion of space itself. Think of it as a balloon inflating, but on an unimaginable scale. Everything, space, time, matter, was created and stretched from this singularity. No one knows exactly what caused this event, but it marked the birth of time and space as we understand them. In the first moments after the Big Bang, the universe was incredibly hot and dense, far too hot for matter as we know it to form. The temperature was over 10 billion degrees, and particles such as quarks and gluons filled the universe, unable to come together to form atoms. As the universe expanded, it began to cool, and after about 1/1,000,000th of a second, quarks combined to form protons and neutrons, the building blocks of atoms. The universe, still a hot and chaotic place, continued expanding, and over the next few minutes, the first simple atomic nuclei began to form, such as hydrogen and helium. Now, nearly 380,000 years after the Big Bang, the universe had cooled enough for electrons to join with protons and form neutral atoms. This cooling allowed light to travel freely for the first time, and it's at this point we see the birth of what scientists call the cosmic microwave background, a faint afterglow of radiation that permeates the universe today. This glow, detectable with the most sensitive instruments, is the oldest light we can observe. It is a snapshot of the universe in its infancy, a relic from a time when the universe was just a few 100,000 years old. Scientists use this radiation to study the earliest moments of the universe, learning about its age, composition, and evolution. Over the next few 100 million years, the universe continued to expand and cool. Gravity began to take hold, causing small fluctuations in the distribution of matter. These fluctuations grew over time, leading to the formation of the first stars and galaxies. The first stars, known as population 3 stars, were massive and short-lived. These stars created the first elements heavier than hydrogen and helium, such as carbon and oxygen. These elements were crucial in forming the planets and life as we know it. One of the most surprising revelations from the Big Bang Theory is the discovery that the universe is still expanding. Galaxies are moving away from each other, and this expansion is accelerating. This observation, first made by Edwin Hubble in the 1920s, gave birth to the idea that the universe is not static, but constantly stretching over time. Today, this expansion is understood to be driven by mysterious forces like dark energy, a force that seems to be pushing galaxies apart at an ever-increasing rate. The discovery of dark energy has reshaped our understanding of the universe's future, suggesting that it may continue expanding indefinitely. But what does the future hold for the universe? Will it continue expanding forever, growing colder and more distant as galaxies move farther apart? Or perhaps, will it eventually collapse back in on itself in a big crunch? We simply don't know yet. The answers lie in further study and observations, but what we do know is that the universe is vast and its history is far from over. The Big Bang Theory gives us a framework to understand the universe's origins. From a single point of unimaginable density, it has expanded and evolved into the cosmos we observe today, a story still unfolding across billions of years. As our knowledge of the universe continues to grow, one thing remains clear: the Big Bang was the beginning of everything. While we may never know everything about the origins of the universe, the pursuit of knowledge will keep us looking up, asking questions, and exploring the unknown. The Big Bang is just the beginning.